So today's lecture we will go through impulse function and more applications about it. So the timeline of today's lecture, which is Monday, we will discuss the impulse function, and the readings are page 30 to 35. And Wednesday, 24th, it will be, the reading will be page 35 to 40. And remember, it's homework 2, the due of homework 2. And more details about homework 2 are written on Canvas, so you can check Canvas to see what's homework 2. The deadline will be at 10 a.m. So please make sure to submit it before the class starts. So, and also on 27, the readings, which is on Friday, will be page still 35 to 40. Next week and Monday will be the math lab projects, the first math lab project. So which is in 29, Monday. Readings are also page 35 to 40, and it's math lab project. So you can see Canvas and see go to the section of math lab project to see what you need to do. This is the due for math lab project. Then on 31st, Wednesday, the readings are page 40 to 50, and it is also the due for homework 3. So a quick reminder, and also I encourage you, I also published earlier this course announcement how to connect your Canvas calendar to your cell phone. So I encourage you to do this so you can have exact timeline, so you can know like the due dates for all the homeworks by looking at your phone calendar. Okay, any question about this timeline? Okay, let's go to the impulse function. We already started talking about the impulse function last lecture, which is basically we denoted it by delta of t. Delta is a lowercase, or we can say delta of t minus tau, so it's shifted by making t equal tau, shifted at tau. Delta of t, which is the origin of the arrow, will be at the 0. Here's delta of t, while delta of t equal to tau, t minus tau, so make t minus tau equals 0, therefore t equals to tau, so it will be located at tau, and that's delta of t minus tau. That's how it looks like. Overall specification, delta of t minus tau, it goes toward the infinity. So that arrow goes toward the infinity. So we cannot say what's the value of delta of t at t equals 0 because it is something unknown. While we can know any other values other than 0 or other than tau, which will be zeros. So it will be happening only at that instance. Something happens at that instant. So the properties for delta of t, which is delta of t equals to 0 for all t not equal to 0. Any value t not equal to 0, then delta of t every time equals 0. Because again, the waveform or the platform is like this. So only at 0 it will be that indefinite value, while otherwise it will be zeros. Then the integral from negative infinity to infinity, delta of t dt, which is if you apply the integral, and as we know the integral is the area, and the area of that arrow actually will be 1. So the integral equals to 1. if you do the integral boundaries between negative infinity to infinity. And the other thing, which is delta of t equals to negative, or delta of negative t. Delta of negative t. Then, another property, if I have a function f of t, no matter what's this function, times delta of t minus tau, so the answer will be f of tau delta t minus tau. So this will affect on the value of the function itself. And this property is very important. Number 5, delta of t is actually the time derivative of u of t. And u of t, which is the unit step function. Okay, step or property number 6. Delta of t minus tau equals to 0 for all t does not equal to tau. Then property number 7. The integral between negative infinity to infinity, delta of t minus tau dt equal to 1, which is the same as delta of t, but now delta of t minus tau. Then, property number 8, delta between t1 to t2, the integral between delta of t minus tau dt. It can be either 1 or 0 depending on the boundary. So, if tau belongs to the period t1 between this boundaries t1, t2, then it will be 1. If tau does not belong to this t1, t2, then it will be 0. Okay, what do I mean by this property? So basically, again, here's the time axis, and let's assume delta of t itself, which is centered at 0. So here is delta of t. So when I do my integration around the 0, I will get 1. If I make my boundaries like negative 1 to 1, then the integral between negative 1 to 1, delta of t equals to 1. But if I make my boundaries outside, like if I make my boundaries, for example, negative 3, negative 2, so the integral between negative 3, negative 2, delta of t dt, what do you think? You are applying integral into this area. It will be 0, because the integral of nothing. There is nothing. So keep in mind the boundaries are very important. While if it is between negative infinity to infinity, then definitely you are covering delta of t. You are covering that arrow. That's our arrow. So keep in mind when you apply your integral, keep in mind if your boundary is between the center of that arrow. So if you are including that arrow or not. So here an example. Let's assume we need to do the integral between negative 10 to 10 delta of t minus 2 dt. So by looking here, it's t minus 2. T minus 2 equals 0, therefore t equals 2. Now, is 2 between negative 10 to 10? Yes, therefore it will be 1. Because again, here is the arrow, here is 2, here is negative 10, here is 10, then you are including the arrow. How about the integral between negative 1 to 1 delta of t minus 2 dt. Now, here t minus 2 equals 0, therefore t equals 2. It is centered at 2. Now, is 2 between negative 1 to 1? No, it is not. So the answer will be 0. Because actually, here is your 2, here is 1, here is negative 1. So you are doing the integral here, and you are not including the arrow. Therefore, it will be 0. So actually, that arrow, as I said, like, this goes to infinity, but it has an area of 1. The area of that arrow is 1. Okay, clear? Now, number 9. Let's go to property number 9. which is the integral between negative infinity to infinity f of t delta t minus tau dt equals, this is f of t times delta according to the procedure of property 4. This is very important. Property 4, f of t delta t minus tau equal f of tau. So substitute tau here. That's what we did. So you will substitute tau here. So it's going to be as the integral between negative infinity to infinity f of tau delta t minus tau. So the only thing that what I did, which is substitute t equal to tau. Now f of tau is constant. It can be kicked out of the integral. So it's going to be as f of tau, then the integral between negative infinity to infinity delta t minus tau dt, and the integral between negative infinity to infinity. This means we are covering the arrow. So therefore it's 1. So f of t times 1, which is going to be, I'm sorry, f of tau. F of tau times 1, then it's going to be as f of tau. Okay? Property number 10. The integral between t1 to t2 f of t delta t minus tau, which is the same as number 9. I mentioned, instead of negative infinity to infinity, I mentioned a time period t1, t2. So it can be either f of t, f of tau. This happens if and only if tau belongs to the period between t1, t2. Or it can be 0 if tau does not belong to the period t1, t2. Which is the same thing if the integral including that arrow or does not include that arrow. Now a question. Find the integral of negative 10 to 10 f of t delta t minus 2 dt. According to this, if you want, you can apply number 10 direct, or you can find, saying here, t equal to 2. Therefore, it will be the integral negative 10 to 10 f of 2 delta t minus 2 dt, which is going to be as f of 2, the integral between negative 10 to 10 delta t minus 2 dt. Since 2 between negative 10 to 10, therefore it will be f of 2. Or you can say direct, apply just property 10. You can say it is f of 2, and since 2 is between negative 10 to 10, then that's it. Another example, if we say like the integral between negative 1 to 1 f of t delta t minus 2 dt, what do you think the answer will be? It's like f of 1, the integral negative 1, I'm sorry, f of 2, the integral between negative 1 to 1 delta t minus 2 dt. So the answer will be 0. Okay? So understanding these rules and applying them, this is very important and very crucial, because we need to use it a lot in later in this course, and also especially you use it later in communication signals in the future courses. Okay. Now, as we know, dy or delta, I'm sorry, u of t, delta of t equals du of t by dt. Now, if we need to calculate u of t, will be the integral between negative infinity to t u of tau d tau, delta of tau d tau. Just do the integral. And I would say this is property number 11. Okay, so let's do the integral. We can define u of t. how can we prove this? Or actually, why we use d tau dt? Because I put t into the integral, so it's incorrect to say negative infinity to t u of t dt. We use tau as a dummy variable. Dummy variable, which is indicates 40 time. Anyway, so how can I just look at this and make sure, or to see the cases? So let's discuss case 1. If t less than 0. So here we are doing the integral of delta tau. So here is tau, and then we make it just only one square. Here's tau, here is 0. So this is delta tau. And if I make t less than 0, which means negative number, here, t. And here is, for example, negative infinity, so my integral here, which is outside of the arrow, therefore, it will be 0. So it's going to be as the integral between negative infinity to t, 0 dt, tau, which is going to be 0. While case 2, if t is positive, then in this situation we will guarantee we are covering the delta inside the integral. So here is 0, here is t, then this is delta t, and here is negative infinity. So I'm covering the delta. Since I'm covering the delta, then the integral of delta is 1. So it will be like integral negative infinity to t delta tau d tau is actually, we can split it into two ways, like it is an integral between negative infinity to infinity delta tau d tau minus integral from t to infinity delta tau d tau. I think you know this from calculus, so just a quick review. The integral from minus infinity to infinity f of t dt equals to the integral from minus infinity to a f of t dt plus integral from a to infinity f of t dt. Then you can just change the output. So this is from calculus. Then let's go back here, substitute the values. The integral from negative infinity to infinity is 1. Then minus t to infinity here is 0, so the answer will be 1. Or, you don't need to do this. You can say directly, this is equals to 1. And 1, which is the same as u of t, because t larger than 0. Okay? Does this make sense? Okay. Now, let's talk more about this function. So, since I say that delta of t equals d u of t by dt, then I can say k delta of t equals to d by dt k u of t, if there is a constant. So, for example, here is u of t, and it's multiplied by k, so k u of t. Now I need to apply the derivative here at t. I need to apply the derivative. So to apply the derivative of u of t, if the constant will be constant, derivative of u of t will be delta. So how can I find the derivative? Since it's the center at 0, here is 0, it will be like this. This is k delta. That's how I find the derivative. So most likely, look at this waveform. Look at this part. This part is 0. The derivative of 0 0, right? This part is constant. The derivative of constant is what? 0. The only thing remains is this transition, right? This transition, this derivative will be infinity, which is this. So actually, delta of t is related to the transition. What's happening here? Which is the derivative of the yellow here, that are marked by yellow. Okay? So transition up to high, high to up, there will be delta of t. Okay, let me give another example, some examples. Here's the example. We have f of t equals 10 u of t plus 1 minus u of t minus 2. Find the derivative of bar of t. So I'm going to find it in two ways. The first way, using the mathematical expression. Using the mathematical expression, f bar of t equals 10, the derivative of u is delta t plus 1 minus delta t minus 2. Well, and that's it. I'm done. Or, method number 2, using the plotting. So I'm going to plot f of t first, then we will plot the delta. F of t here is 10 u of t plus 1, then minus u of t minus 0. Since they are all sharing the same magnitude, then which means on and off. Here it is centered at t equal negative 1. Here centered at t equal 2. So we have critical points at negative 1, critical points at 2. So what will happen? Before t equal to negative 1, everything is zeros. Then when t equal 1, this one will be activated with 10, positive 10, slope. Then at t equal 2, will be the slope is negative, so they will cancel each other, will be 0. That's it. So this is f. Now to find the derivative of bar of t, the derivative of this constant 0, this constant 0, this constant 0, the only thing that remains, which is the transition, right? So these transitions, this goes up to low. This make it the derivative here at negative 1. So this is 10 delta of t plus 1. While the other side, since it goes high to low or low to high, I'm sorry, high to low, it will be negative 10 delta of t minus 2. So transition low to high will be up or increasing, positive, decreasing, negative. Okay? Does this make sense? Any question about these examples? Yes?
So if the arrows are infinity, what is multiplying by 10? If they go to infinity.
Say that again, please.
For the second plot, if those arrows go to infinity, what is multiplying by 10? Does that actually change our answer, or is it still just going to infinity?
It still goes to infinity, but the thing which is constant times infinity equals to infinity, right? But the thing is, the overall area of that arrow will be 1. Then times 10, so it will be 10 times 1 if you do the integral. Another example here. We have f of t as this class, and we need to do the derivative. Here's 2. Okay? Now, this is f of t. We need to find f bar of t. Using two methods, like using the mathematical expression and using the plotting. So let's do the plotting first, then we will do the mathematical after that. So the critical points, here is at 2, here is at -2. So before -2, it's 0, so the derivative of the 0 will be 0. Now, here, between -2 to 0, which is this area, you will see it's constant. I'm sorry, it's a ramp. It's increasing. And it's keep increasing between -2 to 2. So therefore, we need to calculate the slope. If we calculate the slope, then the derivative of a linear curve, which is, if we say like ax plus b, so the derivative of this expression will equal to a, which is the slope. So we need to calculate the slope. How to calculate the slope? You can choose 2 points, like this, choose here, this point and this point. So the slope will be 2 minus 0 over 2 minus 0, so the slope will be 1. Then, during this, it will be 1. After t larger than 0, it will be back to 0 because the derivative is 0. Okay? Then we will say that this is f bar of t equals to u of t, right? So how this is first way. There is another way, which is by doing the other thing, which is the function, how to find the mathematical formula. So the mathematical formula, as I told you earlier, like this is of RAM. Then we will say that let's find the equation, since we found the slope. So I will say like let's find f of t. F of t, since it's RAM and it starts at -2 with magnitude 2, so on the slope 2, so it will be as the slope is 1 times r of t minus t0. So that's how we need to calculate it. So the slope, and since it will go back to 0 here, then minus the same slope times r of t plus t1. So the slope, since we have the slope is 1, so it will be r of t activated at -2, so it will be plus 2. Because here t equals -2. Then subtract it from r of t, it's deactivated at t equal 2. Then here t equal 2. That's f of t. Then if we need to calculate the derivative, f bar of t, the derivative, which is u of t plus 2 minus u of t minus 2. That's what's supposed to be there. Here, when I wrote the derivative is u of t, I was not really accurate, but that's how the derivative will be. So if you want to plot it, it's activated at -2 and will be 0 at equal to 2. Okay? That's a way of how to find this, by finding r of t. Okay? Now, if we need to solve it in different way, if we say, here is, answer right, this is way number 2, this is way number 1, and I will mention way number 3, because we know r of t equals t u of t. So let's rewrite f of t like this. F of t will be t u of t plus 2 minus t u of t minus 2. Okay? Now we need to find the derivative f of t bar. So how to apply the derivative, which will be basically the derivative of the first one times the second one, and then the second one times the first one. So basically, it will be as u of t plus 2, because it's the derivative of t, plus the derivative of u of t, so it will be t times delta t plus 2, subtracted from the derivative of t, which will be, let me say here, the derivative of t will be 1, so it will be u of t minus 2 plus t delta t minus 2. So you can substitute them and reverse them. So from u of t plus 2 minus u of t minus 2, then plus t delta t plus 2 plus t delta t minus 2. Now, what should I do next? Which is how to substitute, how to deal with this expression. I will say this is similar to, let me rewrite it here. Now I need to focus on t, delta t plus 2, and here this is minus sign of subtraction, minus t delta t minus 2. This is similar to f times f of t times delta t plus tau, or we say like minus tau, so we will substitute, it will be f of tau delta t minus tau. So basically, tau here equal to 2, here negative 2, here tau equal to 2, so it will be as negative 2 delta t plus 2, then here minus 2 delta t minus 2. Okay? That's how this expression, so the overall f bar of t will be u of t plus 2 minus u of t minus 2 minus 2 delta t plus 2 minus 2 delta t minus 2. So if we need to plot this, since it's u of t here, here is negative 2, here is 2, here is 1, and what will happen, you will see delta here, this is negative 2 delta t plus 2, and this is negative 2 delta t minus 2. So by looking at answer 3 and answer 1, they are almost the same, but the only thing that we have is the transitions here. So most likely when we do the derivative here, we will neglect the delta. Okay? Again, let's need to focus on this. F of t delta t equals f of 0 delta t. And when we do the integration, we get infinity to infinity f of t delta t. We already written this, but I'm gonna rewrite them just to show them how important it is to use these results. Then when we do the shift, f of t delta t minus tau equals f of tau delta t minus tau. And when we have the integral, infinity to infinity, f of t delta t minus tau dt equals to f of tau. And here I mentioned negative infinity to infinity, but it can be as well between a to b, if a to b range are between the so it can cover the arrow. And if we mention like integral from a to b, it can be if a to b and tau in the middle, then it can be fine. If it's not in the middle, here is a, here is b, here is tau, then it can be 0. Okay? Let's go to more examples. We need to calculate, here's number 1, t delta t plus 2, using the properties. Again, we call f of t delta t minus tau. This is equal to f of tau delta t minus tau. So here, t equal to negative 2, so we will substitute it here. So we will end up having, this is f of negative 2 delta t plus 2, and here f of t is equal to t, so it will be negative 2 delta t plus 2. Now the second thing, which is t delta t minus 2, which is going to be here since t minus 2 equals 0, therefore t will be 2, tau over 2. Then we will do, it will be f of 2 delta t minus 2, and t is 2, is f of t is equal to t, therefore it will be 2 delta t minus 2. Now number 3, we have f of t equals t u of t plus 2 minus t u of t minus 2. I think we already did this derivative, but we already did it here, but yeah, okay, so but I mean the overall thing that whenever we have this property f of t times delta t minus 2, it will be f of tau times delta t minus tau. So you need to just make sure how to substitute them. I'm going to just make number 2, like if we have 2t delta t minus 1 plus t cubic delta t plus 1, we need to simplify it. So here, tau or t minus 1 equals 0, therefore t equals 1. Here t plus 1 equals 0, therefore t equals negative 1. So the substitute here, it will be as f of t delta t minus 1 plus f of, here is f2, here is f1, delta t plus 1. So you can substitute them, it will be as f1 of 1 delta t minus 1 plus here f2 of negative 1 times delta t plus 1. Then substituted here equal to 2t, so 2 times 1, delta t minus 1, here negative 1, so it will be negative 1 cubic times delta t plus 1, so it will be 2 delta t minus 1 plus negative 1 cubic will be negative 1, so it will be minus delta t plus 1. Okay? Now example number 4. We have f of t equals 4t plus 2. But here the question says find the integral between negative infinity to infinity f of t delta t minus 10 dt. So here I'm going to write this as step A or part A. So what should I do? Since it's between negative to infinity and t here equal 2, so this is equal to f of, I'm sorry, t here equal 10 because t minus 10 equal to 0, therefore t equal 10. So it will be f of 10, which will be 4 times 10 plus 2, 40, plus 2, 42. Then, part B, we need to calculate the integral between negative 3 to negative 1. So what should I do? Negative t to negative 1, f of t delta t, I would say like plus 2 dt. So here, look, t plus 2 equals 0, therefore t will equal to negative 2. Since negative 2 is bounded between negative 3 to negative 1, this yes. So the answer will equal to f of negative 2. Now substituting 4 times negative 2 plus 2, 4 times negative 2, negative 8 plus 2, negative 6. Now part number C, calculate the integral between negative 1 to 1, f of t, delta t minus 2 dt. So look at inside the delta, t minus 2 equals 0, therefore t equal 2. Now, is 2 between negative 1 to 1? No, therefore the answer will be the limit 0. Okay, every time when we do with delta, check the integral limits. Is it between the range or not? Okay, there's one example, I think the problem 128c, which is find the integral between negative 3 to negative 1, t power 5 delta t plus 2 dt. So basically, to solve these kind of problems, to avoid the confusion, you can say between negative 3 to negative 1, f of t delta t plus 2 dt, such that f of t equals t power 5. Now look at t plus 2 equal 0, therefore t equal negative 2. Now negative 2, it is bounded between negative 3 to negative 1, that's fine. So the answer will be f of negative 2, which is going to be negative 2 power 5, so negative 32. Okay? Any question? Now another example, I want you to try it. Another example number 5. Which is the integral between negative 1 to 1, t power 5 delta t plus 2 dt. What's the value of this?
0.
0. Why?
Because negative 2 is outside the balance of the interval.
Exactly. So basically, you can make it as f of t delta t plus 2 dt negative 1 to 1, such that f of t equals t power 5. Then here you will say t plus 2 equals 0, therefore t equals negative 2, and negative 2 is not bounded between negative 1 to 1, therefore it's equal to 0. Okay? So that's what you need to know about delta function. Basically the properties and how to do the integral. It's like math, just math. Okay, any question about delta? Okay, so later this course we will go to the exponential function and we will go to the time variable application. So let me to stop here, and next lecture we will continue.